Hi, everyone. So, as we talk about sound energy, it can be tricky in some aspects when we talk about waves, sound waves. So, normally I would have a PowerPoint presentation and you would be taking notes as I was lecturing, going through the presentation. But if you follow along on the notes in front of you, I'm going to read and discuss them. The answers are in red, which means that that is the important term you should be gathering as we talk about sound energy. So there's different types of energy. Energy is the ability to do work. Okay. There's light energy, sound energy, heat energy, mechanical energy, chemical energy, many, many more. So as we start with sound energy, if I were to ask you, what is sound? Well, sound is made when an object vibrates. So when you're talking, singing, you can feel those vocal cords actually vibrating. Okay. The vibration then travels in waves. These are invisible waves, and the waves travel away from the object, away. Vibrations are the back and forth movement of molecules of matter. Sound is then carried to our ears through these vibrating air molecules. Our ears then take in the sound waves and turn them into signals that go to our brain. There's different types of waves. This picture is a transverse wave. When I look at it, and if I were to ask you to label the parts of a wave, the crest. The crest is the highest point on a wave. So where my mouse is, that would be a crest. That would be a crest. That would be a crest. The trough, it's pronounced trough, rhymes with rough. That's the lowest point, right where my mouse is. The lowest point of a wave. So crest, trough. The rest position of a wave is called a node. So right here where this black solid line is, where my mouse is called a node. Sometimes our textbooks just call it the rest position, okay? The wavelength of a wave is the distance from one point on the wave to the next corresponding adjacent point, the wavelength. So from this point where my mouse is to this point, it's the start of the next wave. That would be called one wavelength. And if you are musically talented, you've probably heard of this next word. It's called amplitude. That's the measure of the strength of the wavelength, or referred to as volume. Amplitude is the strength of the wave, and we hear that by the volume. Frequency is a sound vocabulary word. That means it's the number of waves moving past a point in 1 second. Well, the frequency then determines the pitch. The shorter the wavelength is, the higher the frequency and the higher the pitch. Take that in. The shorter the wavelength, the higher the frequency, which is the number of waves moving. It means a higher pitch, higher pitch. The longer the wavelength, the lower the frequency and the lower the pitch. So when you have a low frequency, you're also going to have a low pitch. So here's some pictures in front of you showing different waves. So if I were to ask you, let's take a look where my mouse is right now at this sound wave. If I were to ask you, please describe its frequency and pitch. Notice if you have a low frequency, you have a low pitch. So this diagram is showing me a picture of a sound wave with low frequency and a low pitch. The middle one is medium frequency, medium pitch. High frequency, look how compressed, big word there. Compressed means pushed together, these waves are. So in this diagram, high frequency, that is showing me, telling me that that sound is a high pitch. So really study these three diagrams. Low frequency, low pitch. Notice they're more spaced out. Those waves